we have a factor theorem that says if we divide and we get a remainder of 0, then that term is a factor. It's very simple. It is a factor. So it says use the factor determinant if x minus 5 and x plus 5 are factors of this. Use the binomials that are factors to write the factored form. Okay, so let's first start. I'm going to use synthetic. So I have 1 minus 18. I'm checking to see if there's any missing powers. It doesn't look like there are so far. And 25 there. I'll start with this one. Here, x equals 5. So we're going to divide by 5. So I'm going to pull this down. 1 comes down. 1 times 5 is 5. So that leaves me with negative 13. Negative 13 times 5 is negative 65, which is going to leave me with negative 5 here. 5 times negative 5 is negative 25. So we have 0 for our remainder. So this is a factor. Okay? That's a good thing. Now, when we go to try this next one, here's the deal. You don't have to start back over at the start. If this is a factor, then this ought to be able to factor in as well. And so here, we're going to say that x equals negative 5. So we could use negative 5 and go through this process again. All right? So I don't include the remainder here. So pull down the 1. 1 times negative 5 is negative 5. This gives me negative 18. Negative 18 times negative 5 is positive 90. Okay, and this does not factor because I'm left with 85 is my remainder. All right, I switched colors there just to make it stand out. So this is not a factor here. So I know this one was, and this is my last thing that I know that could be factored. So the factored form of f of x is you could say that f of x would equal that original one, x minus 5. And we go back to here. There was our factor here. And so if I went back to that level, I would have this start off as an x cubed. So this is here an x squared. So we'd have x squared minus 13x minus 5. This would be my factored form. And you could try to factor that further, but you'll find out if you try to do the x method, you couldn't factor that any further. Let's try another one. Okay, so this time we're going to see if x equals 5 can factor into this. So we check for missing powers. 3, 2, 1, 0. No, I look good. So we copy those. And now I'm going to divide by 5. First term always comes straight down. Then you multiply. Product, 1 and 5 is 5. The sum of those two is 3. 3 times 5 is 15. Sum is 2. Product of 5 and 2 is 10. So again, we have 0 equals our remainder. This means this is a factor. This is a good thing. Now we can try again, or if you wanted to, remember how this is x cubed, this is x squared. You could just x method this. We're going to look for factors of 2 that have 3. It's going to be 1 and 2. Let's see here. They want to know if x plus 2 would be 1. So now I'm going to try synthetically. Now we just discovered that this will work because it's going to be plus 1 and plus 2 are the factors. So this should work. Let's try it. So this time I'm going to go here. Pull down. So 1 comes down. 1 times negative 2 is negative 2. The sum of that is 1. Multiply those, negative 2. We get 0. And this is our new remainder. This is also a factor. What does this mean we're left with here? This would simply be x. So the factors of f of x would equal, remember this was originally x minus 5. So we have x minus 5. That's where that came from. This came from x plus 2. And we're left here with x plus 1. Those would be my factors. Now it's your turn to try this one.